One of the first modern snowboards was nothing more than two skis tied together with a rope. But less than a half a century later, snowboards are able to perform like a surfboard, a skateboard, and a set of skis all rolled into one. And to get that kind of performance, you have to layer it in, bit by bit. It starts with making the innermost layer of the snowboard, the flexible wooden core that will get sandwiched inside a protective plastic shell. The kind of wood in the core determines the performance of the board. So to start a core, a worker glues together a mix of woods that together is stronger and more flexible than any single kind of wood. This mix is going into the most popular kind of snowboard, called a freeride or all-mountain board, which, as the name implies, is an all-terrain, all-purpose snowboard. So 80% of the planks in the core are poplar wood because it's both strong and flexible. But about every fifth plank is aspen wood, a wood that's similar to poplar except it's lighter weight, so it adds to the core's maneuverability. After all the planks are lined up, they're clamped together in a vise and left to dry for 8 hours. After the glue dries, a bandsaw slices the combined wooden block into 2-inch slabs to rough out about a half dozen cores. Then, a computer-controlled router shapes each slab into the shape of the core. Like the makeup of the core, there are different shapes for different kinds of boards. For the all-mountain boards, the router shapes the tip slightly wider than the tail, which makes it easier to keep the board pointed in one direction. Freestyle boards, which are best for jumps and spins, are generally shorter and wider so they're easier to turn. While alpine boards are longer and more narrow and designed for hard carving and speed. It takes the carbide cutter just 12 minutes to munch its way through the lumber and create the shape of an all-mountain board. To strengthen the slab and keep it from getting wet on the slopes, plastic sidewalls are cut to line the edges. After the sidewalls are glued on, the slab passes through another bandsaw to slice it down to just 5/16 of an inch thick, which is very close to the thickness of the finished core. Then, a computer-controlled drill drills tiny holes into the core. They'll be used later to attach the bindings to the snowboard. It's important the holes are precise, or the boarder could be in for a bumpy ride. To complete the core, a special profiling machine shaves down the thickness of the wood at just the tip and the tail of the board. The thinner nose and tail keeps the board flexible when it turns, while the thicker middle keeps it strong. But if you tried to ride just the wooden core, the wood would get wet and the board would warp. So to protect the wood and give the snowboard some style, thin sheets of a super light yet ultra-strong polyester-based plastic are printed with colorful graphics to make a plastic top and base for the board. Once the design is set, the plastic layers are placed in a jig to be cut into the shape of a snowboard. A press bears down on the plastic with a thin razor-sharp die that's shaped exactly like the board. But the base isn't ready to hit the slopes until it's lined with the thin metal edges or rails that cut into the snow. Without the rails, the board has no way to grip the slope, and you'd have no way to turn or stop. To attach the rails, a worker lines them up along the sides of the board and then clamps them down so they can be glued into place. Once the rails are set, it's time to press together the layers of the snowboard. The plastic base goes into the press first, along with some black rubber strips that act as shock absorbers. A syrupy liquid resin pours on over the base. It's sticky like glue to help bond the parts together. A sheet of fiberglass goes on next to increase both the stiffness and strength of the board. The wooden core goes on top of that, guided by a red laser that keeps everything centered. A final layer of fiberglass goes on over the wood and is coated in still more resin. And finally, the printed plastic top. Then, the press heats up to 185 degrees and bears down on the layers to melt them all together like a high-tech grilled cheese sandwich. The press also adds a slight curve to the nose and tail of the board, which will help it glide over the snow. Once the resin is set, a bandsaw trims the edges so that everything lines up with the base of the board. Then, the board is in for one crazy ride. First, some 50 grit sandpaper smooths out the rough edges. Next, a grinding stone roughs up the bottom of the board to prepare it for a coat of hot wax. And finally, a buffer waxer machine adds the wax for a super smooth ride across the snow. Then, after a final wipe down, this board is ready to hit the slopes. Next, putting the needle in the needle nose pliers and see what has to go into the police jacket before the badge gets pinned on.